Hello, welcome to SPMM Revision on Demand. In this podcast, I will discuss the concept of effect size. What is effect size? Effect size is the magnitude of the difference between two groups. The magnitude or the size of the difference between two groups on any measure is affected by the degree of variability of the measure across the population. Observing a small between group difference for a highly variable measure is not very meaningful. This can occur even when there is no true difference between the two populations from where the samples are drawn. So effect size measures are generally standardized using a measure of dispersion, that is, variance or standard deviation. Standardization also enables effect size measures to be unitless, making it easy to compare across different studies. There are four commonly used measures of effect size. In this table, I have explained their usage. Cohen's d is by far the most popular one used for continuous measures. Odds ratio and relative risk are used for binary outcomes, while correlation coefficient is used as a measure of the degree of association between two variables. As a rule of thumb, some arbitrary values are being used to interpret the effect sizes. These are listed in the third column. We will consider the first three measures in more detail in the next few slides. Before that, let's consider why effect sizes are thought to be superior to p-values when reporting the results of a study. P-values, by definition, can only inform us whether an effect exists or not. They do not reveal the size of the effect. Further, p-values are highly susceptible to variations in the sample size. In general, larger the sample, lower the observed p-values. P-values are also affected by the issue of multiple testing. This happens when one conducts several tests in a given dataset. This means that we can find at least one difference that surpasses the p-value threshold, though there is no hypothesis to support this observation a priori. Effect size is relatively free of these issues. It's important that both p-values and effect sizes are used in conjunction to convey adequate information when reporting the results of a trial. Effect sizes are very important metrics when critically appraising a study. Ignoring them could be a costly error. A well-known example is the issue of aspirin and prevention of heart attacks. A large trial called US Physician Health Study was conducted to study the effect of aspirin in preventing myocardial infarction. This trial recruited nearly 22,000 subjects over an average of 5 years. Aspirin had a highly statistically significant association with reduction in myocardial infarction, with a p-value of less than 0.00001. This was considered as a compelling evidence. The study was terminated early, and all high-risk patients were recommended to be given aspirin for preventing MI. But the effect size was too small to make a meaningful impact. An ARR, absolute risk reduction, of 0.77%, corresponding to an NNT more than 125, was noted. This suggests that aspirin has an extremely small influence in the context of clinical practice in public health, though the results were statistically significant. Further studies address these issues, leading to a modification of the recommendations to prevent MI. Let's now consider Cohen's d, or standardized mean difference, SMD. Cohen's d is the difference between two group means expressed in standard deviation units. It's used in studies where the outcome is measured on the basis of a continuous variable, for example, weight or any rating scale scores, glucose levels, and other lab measurements. Cohen's d is very popular among researchers who conduct meta-analysis. The formula for Cohen's d is presented here. Pooled standard deviation is derived from the square root of the pooled variance. What does it mean to have a Cohen's d value of 1? Cohen's d equal to 1 is observed when the two group means are one standard deviation apart. This is an impressive and sizable difference. Cohen's d of 0 is observed when the two group means are the same. That is, there is no difference between the two groups. Let's consider the two ratio measures of effect size, relative risk and odds ratio. These represent the ratio between either odds or probabilities of an event in two groups. These are often used in studies where the outcome is measured using a binary categorical variable. For example, response versus no response, remission versus non-remission, etc. The formula for collecting RR, relative risk, and odds ratio, OR, are shown here. What does it mean to have an OR or an RR of 1? RR or OR of 1 is observed when the two groups have the same event rates. That is, there is no difference between the two groups. RR or OR greater than or less than 1 suggests one group has proportionally more events than the other. In general, RR is preferred in longitudinal studies such as randomized controlled trials and cohort studies. OR is preferred for case control designs, but it is also used in other studies. Now it's time to ask yourself a few questions. Thank you for choosing SPM course for your revision.